Hello. Right. Good evening, everyone. So I thought for a change, I will start with the equilibrium tutorial today. The tutorial based on equilibrium, right? Um, we have discussed a lot of questions in energetics, I mean, no, kinetics, and then I thought maybe let us start with equilibrium, then organic chemistry, then kinetics, right? Today. We'll do a few more questions, right? So this is based on chemical equilibrium. Huh? Chemical equilibrium. I hope you have the tutorial with you. Chemical equilibrium. So I think I discussed up to question number 34. That's what I have marked. Starting from question number 35, right? Question number 35. Let me arrange this. Nitrogen hydrogen gases are mixed in a mixture 1 atm, 3 atm partial pressures at a certain temperature. Now, write the chemical equation for the Haber process that produce ammonia. So, hydrogen, you remember Haber process? Hydrogen plus nitrogen is ammonia, at equilibrium ammonia. So, this is your Haber process. So, two nitrogen, three hydrogens. This is what you have. Nitrogen and hydrogen are in a mixture are 1 atm and 3 atm. So, this is 1 atm and this is 3 atm. Right. uh, Partial pressures at a certain temperature. If the partial pressure of ammonia at the equilibrium mixture is 0.4 atm, calculate the Kp. 3 atm mixture, partial pressures at a certain temperature. If the partial pressure, this is 0.4 atm in this same system. 0.4 atm in this mixture, right? So calculate the Kp. Kp is equal to what is that? Partial pressure of ammonia squared gas space divided by partial pressure of hydrogen to the power 3 gas phase and partial pressure of nitrogen. What do you get? You get zero point 0.4 uh, squared divided by 3 to the power 3 times 1. So this is ATM squared, this is ATM 4. So this and this 2. So that is giving you 0.4 squared divided by 3 times 3, 9, 9 times 3, 27. So what did you get? You get 5.925 10 to the power minus 3. 5.925 10 to the power minus 3. APM minus 2. Answer seems to be different. Ne? Hydrogen mixture at 180, we calculate the Kp of the reaction if the partial pressure in the equilibrium mixture. I think 1 atm and 2, 1 atm, 3 atm, maybe it's not specifically mentioned properly. I think maybe it is the initial one, right? Right. So if it is the initial pressure, we'll do it. Right. It is not properly mentioned there. Right. So we'll take this one and then paste it here. So if it is 3 atm, 3 atm here, and this is 1 atm, in the mixture you have 0.4 atm. 0.4 atm means 2 is 2. This is 2 is to 1. So that means 0.2 has reacted. 0.2 atm has reacted. 2 is to 3 means 0.2 times 3, 0.6 has reacted. I'm considering that as the initial amount. Huh? So this is 2.4 atm. This is 0.8 atm and this is 0.4 atm. Right? Okay. So what is Kp? Kp is equal to partial pressure of ammonia squared divided by uh, partial pressure of hydrogen to the power 3 gas. This is also gas, times partial pressure of nitrogen. So this gives you 0.4 squared. This is 2.4 to the power 3 times 0.8. Same usual unit, right? So zero point 0.4 squared divided by 2.4 to the power 3 multiplied by 0.8. Okay, now 0.0144. Okay. 0.0144 atm to the power minus 2. Right? Initial pressure scale application. I think that is, otherwise it is a little confusing. Question number 35 is that. Right. Let us look at question number 36. See whether we can work that out. Question number 36. 1 mole of NOCl is present in a container with a volume of 1 cubic decimeters. NOCl undergoes decomposition heat as follows. So NOCl gas at equilibrium giving you 2NO gas plus chlorine. So this is 2. You start with 1 mole of NaCl. So this is the initial one is 1 mole of NOCl, right? 1 mole. Nothing here, nothing here. If 10% of NOCl is decomposed when the equilibrium reach at 500 Kelvin, calculate the Kc of the reaction at the same temperature. Change is 10%. 1 minus 10% means 1.1 moles. 0.1 moles. If it is minus 10% out of 1, 10%. So 2 is to 2. Look at the laser pointer. 2 is to 2. So if 0.1 has reacted, here also you get 0.1 moles. Chlorine, how many moles? 2 is to 1. That means 0.05 moles. Right? Volume is 1 cubic decimeters. So at equilibrium, 1 minus 0.1 is 0.9 moles. This is 0.1 moles. And this is 0.05 moles. Right. Okay. So now let us calculate the Kc. Kc is given as NO concentration squared. Chlorine concentration to the power 1. Divide by NOCl concentration to the power 2. Now, since the volume is 1, you divide by 1, so concentration and the number of moles are the same. NO 0.1 squared multiplied by 0.05 divide by 0.9. 0.9 also squared. So what is the unit? Moles per cubic decimeter. Kc, that's what they ask. So what is the value? Right. Let us say 0.1 squared multiplied by 0.05 divided by 0.9 squared. 6.172 10 to the power minus 4. 6.172 10 to the power minus 4. Did you all get that answer? Moles per cubic decimeter. Right? Everybody understood that? Haridha, is it clear? Right. That is question number 36. So 36 is also done, right? Let us look at question number 37. See whether we can get that answer also. Question number 37. Read the question and see. Kp of a reaction that produces ammonia by the Haber process is this much at 200, 450. If the ratio of hydrogen and nitrogen starting reactants is 3 to 1, calculate the pressure required to obtain 10% of ammonia by volume, right? So, nitrogen gas, hydrogen gas at equilibrium ammonia. So, this is 2 nitrogen, hydrogen is 3, right? If the ratio of the hydrogen nitrogen starting mixture is 3 is to 1. So if you have n number of moles here, this is 3n number of moles. Nothing else. Calculate the pressure required to obtain 10% of ammonia by volume. Right. So volume ratio is equal to molar ratio. Right. Volume ratio is equal to molar ratio because the entire container has a single temperature, single pressure at the end. Right. Okay. So let us see what is this value, right? So look at this one. Let us say out of that, x is reacted. So this is 3x. This will be 2x, right? So at equilibrium, you have n minus x. 3 times n minus x. This is 2x. Did you understand that? So this is the initial, this is the change, this is the amount at equilibrium. At equilibrium, look at the total number of moles. Total number of moles. What is that? N minus x plus 3 times n minus x plus 2x. Na, what does it mean? 4n minus 4x plus 2x. So meaning 4n minus 2x, right? That is the total number of moles. Out of that total number of moles, the number of moles of ammonia is 2x, right? So volume fraction. What is the volume fraction? Volume fraction is equal to 2x is the number of moles of ammonia. Total number of moles is 4n minus 2x. That value is equal to how much is that? It says 10%. 10% means 10 divided by 100. Did you all understand that? So, what is this? So, you get 20x is equal to cross multiply, yeah? 4n minus 2x. So, 22x is equal to 4n. X is equal to 4n divided by 22. Right? So that is the amount that has reacted. 4 divided by 22. 4 divided by 22 is equal to 0.18. 0.188. 0.18. And it's a recurrent value because you are dividing 2 divided by 11. So it's a recurrent value. So when you want to get 10%, this is the value you should get. Did you understand that? Everybody, you got it? Right? So meaning now you can calculate the equilibrium moles. Equilibrium moles n minus x. Here n minus x. N minus x means how much is that? 1 minus 0.18. 1 minus 0.18. 0.82. Metan 0.82 n. That is 3 times 0.82 n. Here. So this one is 0.36 n. 3 times 0.82 will again 2.46. Everybody understood that? This is the equilibrium number of moles. Huh? This is the equilibrium number of moles. Now let us look at the molar fractions, partial pressures, and convert it to Kp. So what is the molar fraction here? 0.82 N divided by the total number of moles. What is the total number of moles? 0.82 plus 2.46 plus 0.36, 3.64. Make a note, 2.46 N divided by 3.64. Then I know 0.36 N divided by 3.64. No, N, 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 N. So now it will cancel out. 0.82 divided by 3.64 is roughly around 0.225. 0.225. That's the molar fraction. 2.46 divided by 3.64 is 0.675. What is this one? 0.36 divided by 3.64 is equal to 0.098. Everybody understood that. So this is P, this is P, this is also P. This is the pressure. Right. Now let us use the Kp. Kp is equal to partial pressure of, right, let me write ammonia, right? Partial pressure of ammonia squared divided by partial pressure of nitrogen squared. Nitrogen, not squared, times partial pressure of hydrogen to the power 3. The Kp value is given. What is the Kp value given? 4.25 10 to the power minus 15 right? Partial pressure of ammonia 0.098 P squared divided by partial pressure of nitrogen. Let me double check. Make a nitrogen. Nitrogen is 0.225 P. Partial pressure of hydrogen 0.675 P to the power 3. Right. Now you can get a term of pressure and you can calculate it. Right. So what is this? I will simplify the right hand side. 0.098 squared divide by 0.225 divide by 0.675 to the power 3. It gives you 0.1387. 0.1387 divided by P4 squared, P2 squared. 4.25 10 to the power 15. P squared is what? How much is P squared? 0.1387 divided by 4.25 10 to the power minus 15. The 3.26 10 to the power 30. 3.26 10 to the power 30. Pascal squared. For what is the pressure? Pressure is the square root of this. You got 5.7 here, 5.7 10 to the power 1, 2, 3, 4, 5, 6, 10 to the power 6 pascals. What is the answer? Answer 5.7, 5.83. Did you all understand that part? Like a product complex, I will tell you easy way to do it, but did you understand the method? Mama nikam pretty easy technique ka denna. Right? Okay. So, we'll try a easy technique. Easy technique, right? When you have this ammonia based questions are a little difficult because there are so many powers. So let me tell you a kind of a easy technique to do this. Nitrogen gas plus hydrogen gas, and that is at equilibrium ammonia, 2 ammonia, right? You can make a 3 hydrogens, huh? Right. So this says it is 10%. 10% means out of all the number of moles, ammonia is 10%. That means molar fraction is 10 divided by 100. No, this is the molar fraction. Number of moles is proportional to the molar fraction, right? So if this is 10%, that means the remaining amount is 90%. The entire thing is nitrogen, remaining nitrogen and hydrogen is 90%. 90% is divided into, this is 1 to 3 ratio, because you start with 1 to 3 ratio, right? 90% is divided in 1 to 3 ratio. So 90 divided by 4, 22.5. This is 22.5 out of 100. Make a multiplied by 3, 67.5 out of 100. Then lazy. No. If the molar fractions are there, you know this is the pressure, this is the pressure, this is the pressure. And you can get it to Kp. Kp is equal to partial pressure of ammonia squared. Divide by partial pressure of nitrogen gas. Make up gas, huh? Times partial pressure of hydrogen to the power 3. Kp, they have given the value. 4.25, 10 to the power minus 15. Pascal to the power minus 2. Go to ammonia, you get it 10 divided by 100 P squared over 22.5 divided by 100 P. This is 67.5 divided by P divided by 100 to the power 3. But 100 squared, 100 squared cancels out. This becomes 100 squared because there's one remaining. Pressure squared, pressure cube cancels out. This becomes pressure, this one. So what is that? 4.25 10 to the power minus 15 is equal to 100 squared, this part. Here, this part 100 squared. When you take it over there, up there, what you get? 100 times 100. And here also there is another 100. Divide by 22.5 times 67.5 to the power 3 and P squared. So what is P squared? P squared is 100 multiplied by 100 multiplied by 100 divide by 22.5 divide by 67.5 cube. And that is divided by 4.25 10 to the power minus 15. And you need to get the square root of this. So 5.8 kilo pressure, 5.8, 10 to the power, whatever the value, 1, 2, 3, 4, 5, 6. 6 pascals. This is easy. This is the easy way to do it, right? Right? Rather than going through this kind of a lengthy process. I did that lengthy process just to say that these are divided 1 to 3 ratio. Okay? Because this is 1 to 3, this is 3 and this is 1. This is 1 to 3 ratio, it is divided. Now you can directly use that concept. You can directly use that concept and straight away calculate the molar fraction easily. So this is the easy method, easy method. The other one is little difficult. It will take more time. But did you understand that? Everybody. Is that clear? Question number 37. Right. Over the everybody, is that clear to you? Right? What is it? Others also tell me what is going on. Is it clear? Were you able to do it? Did you get those answers? Hemanan, shall we look at 38? Question number 38. Question number 38. Sorry. Let's do that. Methane and steam are present in a flask at 700 Celsius. Remember steam, methane reforming to generate hydrogen for the Haber process. In that, you get carbon monoxide. You turn this carbon monoxide into carbon dioxide. Done. Further. Steam, methane are present in flask. Partial pressures of both gases at the beginning is 2 pascals. So you have methane and H2O. Methane gas and H2O gas. Giving at equilibrium, giving you carbon monoxide gas and 3 hydrogen. So at the very beginning, it says 2 pascals. Make it 2 pascals. This is also 2 pascals. That means same number of moles. Right. 40% of methane is converted to carbon monoxide when the following equilibrium is reached. So 40% means that is the number of moles. Pressure also changed by 40%. So 40% out of 2 is, how much is that? 0.8 pascals. So here it is 0.8 pascals reduce. Here also it is 0.8 pascals reduce. Here you get plus 0.8 pascals and 1:3. So this is 2.4 pascals. So you get 1.2 pascals. Here you get 1.2 pascals. Here you get 0.8 pascals. Here you get 2.4 pascals. No, right? Okay. Equilibrium, calculate the Kp in that reaction. So what is Kp? Kp is equal to partial pressure of carbon monoxide gas times partial pressure of hydrogen, right? Always in a constant volume, number of moles is proportional to the pressure. Always it is like that. Partial pressure of methane gas times partial pressure of water. Okay. Carbon monoxide, 0.8 pascals. Hydrogen, 2.4 pascals cube. Methane, 1.2 pascals. 1.2 pascals. So what is the value? 2.4 to the power 3 multiplied by 0.8 divide by, what is that? 1.2 times 1.2. 7.68, yes. 7.68. 7.68 Pascal squared. I want to check whether you got the idea. How do you work with pressure skeleton? Can I know how did you get 0.8? So it says 40% of methane is converted. So what is the converted? Out of 2 pascals, 40%. 40 divided by 100. So this is 4 times 2, 8 divided by 10 is equal to 0.8. So that's how you get the zero point 0.8. That is the amount that has reacted. Did you understand that? Right. Is it clear? Zero point 0.8 is the amount that has reacted. 40% of methane has converted. Everybody got it? Children? Any other questions? Right. Good. Okay. Very good. Then I'll move on. If there's anything, any doubt, don't keep it. Don't keep it. Can always ask. Right. Okay. Question number 39, Balam. Question number 39. Right. Read the question. Sulfur dioxide gas is reacted with oxygen to produce sulfur trioxide under favorable conditions when a catalyst is present. If the standard enthalpy of formation are respectively, calculate the standard enthalpy change. You know, delta H reaction is equal to, what is that? Summation of the enthalpy of formation of the products minus summation of the enthalpy of formation of reactants. How many can? Products. Products is sulfur trioxide. What is sulfur trioxide? 395 minus 395 multiplied by 2 minus, what is that? Minus 296 multiplied by 2. Oxygen is 0 kilojoules per mole. So what is that? 395. 395 minus 296 multiplied by 2. 198 minus 198. That's okay na? In analytics. Right. Partial pressures of sulfur dioxide and oxygen and sulfur trioxide is this much, this much, this much. Calculate the KBE for the reaction. At equilibrium. Right. So sulfur dioxide plus oxygen, sulfur trioxide. SO3. This is 2, this is 2. 0.56 atm. Sulfur dioxide is 0.56 atm. Oxygen is 0.1 atm and 0.35 atm. Calculate the Kp. Kp is equal to, what is Kp? Partial pressure of sulfur trioxide gas squared divided by partial pressure of sulfur dioxide gas. Again squared times partial pressure of oxygen gas. What did you get? 0.35 atm. 0.56 atm squared, right? Oxygen is 0.1 atm. So you get the answer as atm minus 1 per atm. What is the value? 0.35 divided by 0.56 and the square term divided by 0.1. Are we 3.9? Yes, 3.9 per atm. Where? You got it? Explain how the partial pressure of sulfur trioxide changes when the temperature of the system increase. Now you all know that this reaction is an exothermic reaction. So if you look at sulfur dioxide plus oxygen, sulfur trioxide, this reaction is an exothermic reaction. The energy is in this side, exothermic. So when you increase the temperature, backward reaction will favor. Reverse reaction will favor. So what will happen? Partial pressure of sulfur trioxide should reduce because it favors in the reverse reaction. Should reduce as reverse reaction is favored. 3.9 ATM per ATM. Question number 39 is that. Did you all understand that, children? Those who have tried it, then if you even if you haven't tried it, you should be able to do it now. Right? Right. Okay. Let us do question number 40 also. Question number 40. Right, are you with me on this? Right. 2 moles of HCl5, 2 moles of HCl3, and 2 moles of chlorine are at equilibrium at 40 Pascal pressure at a certain temperature. Calculate the Kp. Right. You have HCl5. It's gas. Gas. And HCl3. Gas plus chlorine. Right. Oh, pressure. All gases. I think it is better. Right. Gases. Huh? All are gases. 2 moles, 2 moles, 2 moles. This is 2, this is 2, this is 2. 40 pascals. Now the 1 over 3, 1 over 3, 1 over 3. Partial pressure is P, P, P. What is Kp? Kp is equal to partial pressure of HCl3 gas times partial pressure of chlorine divided by partial pressure of HCl5. P divided by 3 multiplied by P divided by 3 divided by P divided by 3. Make it. So what do you get? Pressure is 40 divided by 3 ATM. ATM or Pascal? ATM. So what is that? 40 divided by 3? 13.33. ATM. Oh, Pascal, sorry. Pascals. Pascal, this is also Pascal. 40 Pascals. Right, 13.33 Pascals. Right, okay. Correct the answer. 13.33 Pascals. The value is right, unit is wrong. Chlorine was added to the starting equilibrium system when the temperature and the pressure were constant. If chlorine was added until the volume of the system reaches twice, calculate the number of chlorine moles added to the new equilibrium system. Right. So you have again, on the prashna, HCl5 gas at equilibrium, HCl3 plus Cl2. Okay. You had 2 ATM, the 2 moles. The 2 is moles. Sorry. 2 moles, 2 moles, and 2 moles. Now what you do? You add the chlorine to this. Make it a chlorine dara, right? So let us say you add X moles of chlorine to it. අපි දන්නේ නැහැ. දාගෙන යනවා X moles of chlorine. When you add chlorine, it doesn't wait till it reaches equilibrium. It starts to reach equilibrium. According to the Le Chatelier's principle, when chlorine concentration increases, backward reaction will favor. The backward reaction will take place. Backward reaction is going to take place. So what is the backward reaction? So this is the, let us say, total amount of chlorine that was added is X. Y reacts. The reaction favors in the backward direction. Y. So here also Y. Here you get 2 plus Y. Right? This is the added amount. Everybody understood that? right? Can't you write the reaction in the other direction? It's okay. Then you will get a different value, right? You can write that. No problem. Right. So the reaction favors the way that I have written. Reaction take place in the backward direction. So what is the amount? So plus y. This is I will erase this one. This is y plus y. So what is the amount at equilibrium? 2 plus y. මෙතන එනවා. හරිද? 2 minus y. Here 2 plus x minus y. These are the number of moles. Did you understand that part? ඒක තේරුණාද? Right? Anybody who want me to explain it further? Right? When you add chlorine, the backward reaction will take place. Gradually begins to appear. Right? Is it clear? Right. Okay. If you don't understand, right? Okay. So backward reaction will actually take place. Until now, finally, the volume has become double the value. Until the volume of the system reaches twice. Right? So, meaning, if you apply PVNRT to the initial case, PVNRT to the initial case, pressure, volume. What is the volume? Volume is V. Number of moles is 6, R and T. Pressure and temperature are constant. Make pressure here. Same pressure, volume, same volume. Number of moles here 2226 plus x minus 1. Total number of moles is, make a total number. 6 plus x minus 1. RT. Did you understand that? Now what you can do is you can divide them. See, 2 divided by 1. 6, make a 2v. The volume is 2v. 6 plus x minus y divided by 6 is equal to 2. Volume twice the value. The volume until it becomes twice the value. So 6 plus x minus y is equal to 12. So now you all know x minus y is equal to how much? 6. X minus y is equal to 6. Did you understand that? What is the total number of moles? Total number of moles is 6 plus x minus y. Then x minus y you have counted as 6. 6 plus 6 is 12. Total number of moles is 12. Here you have my total number of moles, but we have calculated x minus y calculate 12. Right. You can you know the molar fractions now. What are the molar fractions? This is the number of moles, 2 plus y. Divide by total number of moles is 12. 2 minus y. Total number of moles is 12. 2 plus 6 x minus y. Are you all paying attention? 2 plus x minus y. X minus y, you know it is 6. Again, 2 plus 6 is 8. 8. 8 divided by 12. Did you understand that? Pressure is constant. 40 pascals. So multiplied by 40. Multiplied by 40. Multiplied by 40. That gives you the pressure, partial pressures. Is it clear? This is 10. This is 3. This is 10. This is 3. This is 10. This is 3. Now, 10 times 2 plus y divided by 3. මේකත් එහෙමයි. 2 minus y times 10 divided by 3. This is 80 divided by 3. They are the partial pressures. For the partial pressures, now equilibrium constant, it doesn't change if the temperature is constant. So now you apply it to Kp. Kp is equal to partial pressure of HCl3 gas times partial pressure of chlorine gas divided by partial pressure of HCl5. You got this Kp as 40 divided by 3. මට මතක හැටියට නේ. නේ. 40 divided by 3. හරි. දැන් ඒව දාමු මේක. Right. HCl3 10 times 2 minus y over 3 multiplied by 80 over 3 divide by 10 2 plus y over 3. බලන්න හොඳට තියනවාද කියලා 3 and 3 cancels out, 10 and 10 cancels out, 3 and 3 cancels out. Make a 40 and this is 2 නේ. Go to 2 plus y is equal to 2 times 2 minus y. මේ කියන්නේ කීයද? 2 plus y is equal to 4 minus 2y. And 3y is equal to 2. Y is equal to 2 divided by 3. I mean, that is not what they asked. They asked you to calculate x. X කියලා කියන්නේ මොකද්ද? X minus y is equal to 6. Minus y is equal to 6. So therefore x is equal to 6 plus 2 divided by 3. දහටයි දෙකයි 20. 20 divided by 3. බලන්න හරිද කියලා. Whether you understood this. මොකද්ද 2 plus y කියන්නේ? I just made cross multiplication නා. මෙන්න මේක මේ. මේකනේ. So 2 times this is doesn't work well. Right? Is it clear? There's 2 here, 2 minus y. And this side cross multiply, yeah? Everybody got it? Question number 40, up to 40. Right? අනික් එක අපි next time will do it. Right? Question number 41. Well, කරන් තියන්න. 41 to 45 next week. We'll work it out if there are. Okay, right, good. So next week 41 to 45 in that equilibrium questions. Work them out. මම ඒවත් discuss කරනවා. Right? හරි. Now we'll go to the organic part. Organic part. I think I discussed this. We were doing alcohols tutorial, right? We were doing that. And then I think we came up to page number 5. We completed page number 5, right? And then page number 6 and onwards in the organic one. Right. So what is the first one? Make it CH3, CH, CH3, CH2OH. And they are being asked to convert it to this one. CH3, CH3, this is H, and CH2, COOH. Yeah, CH3, CH2, COOH. What is the best method? You all can write the reagents. 1, 2, 3, and 4. One, you have to increase the number of carbon atoms. PCl5, heat, or PCl3. HBr. ඕන එකකින් පුළුවන්, right? CH3 and you get CH2Cl. And then you add aqueous alcoholic KCl. Aqueous alcoholic KCl heat. Right? නිකන් reagents එක ලියන්න නිකන්. කොහොම ඉන්න එකේ. Right? Now you all have done it. CH3, thought you will remember it again. CH2Cl. What is the next method? Next thing is Cn to COOH. You add H plus H2O. H2O. Hydrolysis of this compound. Everybody? Yeah, right. Very good. Thank you. Right. Try the next one. The next one is this CH3, CH, double bond CH2. And you have to convert this into CH3, CH, CH3, COOH. You have to attach the molecule into the center. So what is that? It's very easy to attach it to the center. HBr without any peroxide. CH3, CH, CH3, and this is Br. And then what you do is you add the aqueous alcoholic KCl. You add the aqueous alcoholic KCl, CH3, CHCl. CH3, and then you add H plus H2O. H plus H2O, right? Let's look at the next compound. So what is the next one? Next one is the third one. Let me get some pages here, otherwise get stuck all the time. Right, look at the next one. Next one is this one. CH3, CH3, CH2, 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 OH. And then you convert it to CH3, CH, COOH, CH2, CH3. It's an active compound. It's an alcohol. So you can swap the double bond, right? Get the double bond. Concentrated sulfuric, right? 170 degrees heat. You get the compound here, CH3, CH2, CH, double bond CH2. Now add the HBr without any peroxides. So you get CH3, CH2, CH, Br here, CH3. Now once you have the Br there, you can turn this into COOH. Aqueous alcoholic KCl. What do you get? CH3, CH, and then now CH, Cn, CH3. Now once you come up to that point, you can add H plus H2O. It's in the second position, na? H plus H2O. So if you consider this to be 1 and 2, in this one here 1 and 2. You don't have to do anything else to this one, right? And very good. Right, very good. Can we add a carboxylic acid to a benzene ring as a meta-directing group and add groups to the meta position? Yes, you can do that. You can do that. Nitro විතරයි බැරි, right? Nitro විතරයි බැරි. Like, you can attach to this. Right? අනිත් එකත් බලන්න. Right? Next one is CH3, CH2, CH2OH. And then you turn this into CH3, CH, CH2, this is OH, this is OH. What is the method? Concentrated sulfuric, 170 degrees. And then you get CH3, CH, double bond CH2. And then basic potassium permanganate. Basic potassium permanganate, you make it basic, so by using sodium carbonate, KMnO4. Alkaline, cold alkaline potassium permanganate. That is what we write. Right, very good. It was අනික් එක, right? OH to NH2. So how do you convert this OH to NH to CH3 CHOH? And then this is CH3 and you want to convert it to NH2. CH3 CH and this is turned into NH2 and then CH3. React this with PCl5. Heat and then you get the chlorine, 2-chloro-propane. What is that? It's a nucleophilic substitution reaction, PCl5 reaction. And then you add excess liquid ammonia, not aqueous, excess liquid ammonia. Aqueous ammonia, if you add, it has hydroxide, so hydroxide has a possibility of attack, right? Liquid ammonia is the one that should react. CH3OH, ඒක පුළුවන් CH3OH, Cl, Cn, COOH. Right? I did not write it. Right? What is the next one to do? How do you do the next one? CH3, CH2, CH2OH. You go from CH3, CH, CH3, make a CH3. So to do this, you need to increase the number of carbon atoms. Grignard is the best choice to do that. Concentrated sulfuric, 170 degrees Celsius. Get CH3, CH, double bond CH2, dilute sulfuric, CH3, CH, OH, CH3. Okay, but you can do the Grignard and the bromine and attack it also. But it's a better method of doing this. ඒකයි මම මේක ගන්න. හරි? Which plus KMnO4. You get CH3, C double bond O, CH3. Now add the Grignard. CH3, MgBr. Dry ether. Water. You get CH3, COH, CH3 and CH3. Sulfuric. And then you get CH3, CH3, double bond, CH2. And then you can do hydrogenation. Well, there's another method where you turn this into add HBr. CH3, CH, CH3, this is Br. Then you can get Grignard, CH3, MgBr. But that is not a very good method. Like, the yield is not that great. That's why we use it like this. Right. Right. Is it clear? Who reacts faster in Lucas reagent? Compound these two compounds. This is CH2OH. This one. Who reacts faster? Seems to be a tricky question. Who reacts faster? Make faster react. Even though it's a primary alcohol, it gives you a very stable carbocation. Right? So that is the one that reacts. Because compared to inductive effect, resonance effect has a bigger effect. Clear? Right, okay. What is the next one? Next one is this kind of a compound. Right? So CH3, CH, OH, CH2, COH. And then you've been asked to convert it to CH3CH, CH, COH. So methana CN, here also CN, right? So if you look at this one, you have to concentrate a sulfuric. You get CH3, CH, double bond CH, COH. Add bromine to this. CH3CH, CHCOH. And this vicinal dibromo compound, right? And then you can add aqueous alcoholic KCl. Okay, that CN won't attack there, right? Why? Because in order to attack the aldehyde, you need to have the acidic conditions. Sulfuric and sodium cyanide. This is aqueous alcoholic KCN. That's it. Next one is, what is this? CH2OH. And then turn this into CH2D. How do you do that? PCl5, CH2Cl, then Grignard, magnesium diether, CH2MgCl, and then add D plus D2O. Right, so clear? Right. So state the following statements whether they are true or false. Part 7. Na? State the following statement. Alcohol show acidic behavior because of the polarization of the OH bond and react with sodium, liberating hydrogen and forming sodium alkoxide. So alcohols, when you have a OH here, it because there's a polarization, it breaks. This is delta plus and this is delta minus. And if you add sodium here, it will react. You get CONA minus plus, and you get hydrogen gas. So I think that's a right statement. All alcohols react with sodium hydroxide. That is wrong. None of the aliphatic alcohols react. Phenols react, but none of the alcohols react. Alcohols undergo electrophilic substitution reaction with HBr. So alcohols, CH3OH. And what you have is HBr is the one that we add. This one is going to attack onto hydrogen, breaking the bond. So it's acting like an electrophile. So HBr acting like an electrophile, CH3OH2 plus. And you get Br minus. This is going to attack. This is going to leave. So what you get? CH3Br. Right? So if you look at this reaction, it's a electrophilic substitution reaction. So it begins as a HBr acting like an electrophile. I think that is right. It's an electrophile. So this is taking electro. Alcohols react with HCl only in the presence of a Lewis acid or acids. Right? If you add concentrated HCl, you are adding zinc chloride. Right? Normal HCl doesn't work. HBr, HI works. So that is also right. Reacts with HCl only in the presence of this. Primary alcohols in the presence of Lucas reagent form a turbidity in a very short time. That is wrong. Primary alcohols never. Tertiary alcohols are the ones that will react. Oxidation of alcohols can be carried out with acidic potassium permanganate, potassium dichromate, or potassium chrome. Right, that is right. 2-methyl propan 2-ol gives ketones with acidic potassium permanganate. 2-methyl. 1, 2, 3. 2-methyl propan 2-ol. Very good. So that cannot undergo oxidation because there is no hydrogens directly attached to carbinol carbon. Ethanol is oxidized to ethanoic acid by PCC. PCC turns into an aldehyde. That is also wrong. Ethanoic acid by PCC, that is wrong. Right? That is very right? Ethanol means CH3, CH2OH. It turns into aldehyde, CH3, COH, aldehyde, PCC. Phenols are more acidic than alcohols. That is true. Friedel-Crafts alkylation reaction cannot be carried out with phenols because of the complex formation between Friedel-Crafts catalyst and the phenols. That is also true because phenol is highly reactive. When you have FeCl3, immediately they will start interacting with the nucleus. Explain why phenols do not undergo nucleophilic substitution reaction unlike alcohols. If they ask you to explain this, what you need to write is you need to write the resonance structures. So it's phenols. The phenol has a resonance structures like that. So what you have is you have double bonds here. There's a double bond OH plus negative charge. Negative charge goes over here, right? And then we worked on this one. So likewise, need to write the resonance structures. And right? And need to show that there is a double bond character between the carbon and the oxygen in many of these things. So here there are a lot of structures. We have a carbon and oxygen double bond character. So it's very difficult. Partial double bond character, difficult to break. So therefore, it doesn't participate in nucleophilic substitution reactions. And you have to leave it also. Right. Are there any questions here? If the acidic character increases, does it mean the basicity decreases? Yes. When the acidity increases, can the acidic character increases? Basic property decreases. I don't know that. Right? You know, Ka times Kb is equal to Kw. So, right, Ka is equal to Kw divided by Kb. Ka is inversely proportional to Kb. Kb, this is B. Whenever the Ka increases, that means Kb decreases. Inversely proportional. Is it clear? So when the acidic character increases, that means the basic character decreases. Can you explain the last question again? Again, last question again, what is this? May explain why phenols do not undergo nucleophilic substitution reactions unlike alcohols. So when you have a phenol has a partial double bond character. There's a double bond character between the carbon and the oxygen. If you look at alcohols do not have that. The COH, so you can easily break it. This requires a higher amount of energy. Bond dissociation enthalpy is very high. So you need more energy to do that. So it can't break and undergo substitution. In order for the substitution to take place, it should break also. The bond should break. So it can't break. So therefore, substitution doesn't take place. Clear? Right. So that is alcohols. Right. So next week we will start with another aldehydes and ketones. These alcohols and phenols both are there. So aldehydes and ketones. Right. Finish it and we'll discuss that. All right. Clear there. Right. Okay. Yeah, I kinetics ටිකක් කරමු. And just to remind you. හරි එතකොට මම I think kinetics questions 45th one I discussed it last week. අද තව ටිකක් කරමු පොඩ්ඩක් නිකන් නිදිමත එනකම්. තව චුට්ටක් කරමු. Right? Chemical kinetics. එතකොට now in the class that I will start discussing acids bases that tutorial and I have given solubility product tutorial also. හරිද? ඒක ටික ටික කරන්න because these tutorials are very මම මගේ හින්දා කියනව නෙවෙයි මේ very good. මොකද මම like sometimes like when I look at some of those papers I see very similar questions from that tutorial. මම මේ question එක ආවට පස්සේ ටියුට් එක හදලා නෙවෙයි. Like there's very few tutorials that I have made the very early times. Very recently also I saw a very similar question appeared in last year's paper. My last year paper I didn't see yesterday the question මට හම්බුනේ මේ paper එක. ඉතින් අන්න ඒකයි. Like, so you see very similar questions there. හරි. ඒක හින්දා ඒක කරන්න ඒ tutors එක like ටික ටික කරන්න. Right? I know there's a lot of work these days. ඉතින් එහෙම තමයි. When you are very closer to the finishing point, there are a lot of things going on. හරි ඒක give up කරන්න නැතුව ටික ටික කරන්න. It'll be okay. Right? හැම ටියුට් එකෙම ප්‍රශ්න ටිකක් කරපුවාම හරි. You'll remember also. හරි. Don't take it as a burden. හරි. Hydrogen gas, question number 46. The hydrogen gas used to reduce NO into nitrogen. So this is 2 hydrogen gas plus 2 NO gas giving you 2 H2O and then nitrogen. Right? So got to make it like very similar questions here. Calculate the order with respect to hydrogen, nitrogen, derive the rate equation, rate constant. Just to remind, rate is equal, what is that? K times hydrogen gas concentration, the squared, no, squared no x, and then NO concentration y. So whenever you write this, you have to write the now these are x and y are orders, k is the rate constant. You have to always write this. And people say, like, let us substitute this initial rate. Initial rate is what is given, na? 0.0248 moles per cubic decimeter per second is equal to k times 0.212 moles per cubic decimeter to the power x 0.136 moles per cubic decimeter to the power 1. Make a point. You say 0.248. 0.991. 0.0991. Don't do it at the exam. Now we need to look at the answers and move on a little quickly. Right? X and 0.272 moles per cubic decimeter y. The other one is 0.793 is equal to k times 0.424 x 0.554544 to the power y. Just to look at the answers, right? What you do? Make a equation 1, this is equation 2, this is equation 3. Let us take the equation 2 and divide by equation 1. What did you get? 0.991 divided by 0.248. Here then 0.4 again, right? It's a 4. 4 is equal to 0.262 2 to the power y. Y is equal to 2. Check whether you get those answers. It was say if you look at this next one, third one, right? Third one divided by second one. What is that? 2 to the power x multiplied by 2 to the power y is equal to 0.793 divided by 0.0991. Here then 8 again, right? 2 to the power y is equal to 4. 2 to the power x is equal to 4. And x is also equal to 2. Right? Orders are 2 and 2. Anybody has done it? You got to derive the rate T equation. Rate T is equal K times, what is that? Hydrogen to the power X. Did you get that answer? Hydrogen power to the power 2, NO gas to the power 2. Right, okay. So there's people confirming it. Rate. We'll substitute to the first one. 0.0248. Moles per cubic decimeter per second is equal to K times 0.212. 0.212 moles per cubic decimeter to the power 2. And 0.136 moles per cubic decimeter to the power 2. What is K? K is equal to 0.212 squared multiplied by 0.136 squared. 0.0248 divided by this. 29.83 29.83 moles per cubic decimeter dm 9 moles minus 3 per second. Those who have done it. X should be 1 kilo. X is 1. Is that what you get? It should be 1, right? Okay. X is 1, right? Okay. 1 kilo. Then I have to make a I think it's a simple one. Question number 47. Question number 47. Question number 47. Right. NO and hydrogen react with each other as shown below. NO, nitrogen, water, nitrogen. Some experimental data is obtained here. Right. Right. So rate is equal K times NO gas to the power X, hydrogen gas to the power Y. So I'm not going to hurry things up. Make a lesson to hurry. Right. So rate is equal to 0.033. 0.033 moles per cubic decimeter per second is equal to K times. Then make a 2 10 to the power minus 3 moles per cubic decimeter to the power X. The 1.2 10 to the power minus 2 moles per cubic decimeter to the power Y. Right. The other one, 0.03 is equal to K times, this is 6 10 to the power minus 3 to the power X. Make a 1.2 10 to the power minus 2 to the power Y. Methane 0.02 K times, what is this? 1.2 10 to the power minus 2 X. 2 10 to the power minus 3 Y. This is 0.04 is equal to K times 1.2 10 to the power minus 2 to the power X. 4 10 to the power minus 3. Right. what is meant by the order of the reaction? Order of the reaction is how rate of a reaction depends on the concentration of the species, in the rate flow. So, order how the rate of a reaction depends on the concentration of a species in the rate flow. This is measured experimentally, right? You measure this experimentally, you calculate this experimentally by doing experimental and calculate the order with respect to NO, calculate the order with respect to hydrogen. 1 divide by, or 2 divide by 1, 2 divide by 1. What is that? 0.03 divided by 0.033. 6 divided by 2. 3 to the power x is equal to 1. X is equal to 0. Is that what you get? What are 0.03, 0.033. What did you get? Yeah. X is equal to 0. Yeah, right. What is the next one? Let us look at make right. 4 and 4 and 3. 4 divided by 3. This is equal to 2. 4 divided by 2 to the power y. 2 to the power y. Y is equal to 1. Y is equal to 1. Right. Calculate the order with respect to NO. Order with respect to NO. Order with respect to NO is 0. Order with respect to hydrogen is 1. Right. Use the results obtained to above to write the rate expression for the reaction using K as the rate constant. So, rate is equal K times Y to the power 1. Look at the Y. What is Y? Hydrogen. Hydrogen gas to the power 1. Right. Okay. Calculate the value of the rate constant K. Right. Let us use the last one. 0.04 moles per cubic decimeter per second is equal to K times, what is the hydrogen concentration? 4 10 to the power minus 3 moles per cubic decimeter. So this and this cancels out. K is equal to 0.04 divided by 4 10 to the power minus 3. Again 10 10 per second. Is that what you get? Right. Calculate. Explain the reason for the increase in the rate of the reaction when the temperature is increased. Temperature is increased. When the temperature is increased, there are two things that will change. The number of collisions increases. Number of collisions. Collisions increases. The number of collisions taking place in the desired orientation with the right amount of energy increases. Second one, the change in the Boltzmann distribution curve, right? So if this is the distribution at a lower temperature, this is the distribution at a higher temperature, T1 and T2. T2 is greater than T1. So anything that has overcome the necessary activation energy barrier has gone up. Overcome the activation energy barrier has gone up. So therefore, the reaction takes place. Then it says, is the reaction above exothermic, endothermic? Give reasons. Sorry, hydrogen. Hydrogen, H, H. Hydrogen, H, H. NO, double bond NO, 2NO, giving you H2O. H2O. and then you get nitrogen, triple bond. Man. So you can see, make a single bonds, dekai, right? You can see now, like you are breaking a single bond. You're breaking a single bond. You have to break a double bond. You have to break a double bond. Here, oxygen, hydrogen, single bond, oxygen, hydrogen, single bond, oxygen, hydrogen, single bond. And you have to make a triple bond, which is a very strong bond. Did you understand that? So you are breaking weaker bonds to form here a large number of bonds and also stronger bonds. Then, with a single bonds 2. Here single bonds 4. You are forming 4 single bonds. Double bonds 2. Make a triple bond 1. Right? So, right, small amount of energy is absorbed and large amount of energy is released. Right? Large amount of energy is released. Therefore, what will happen? It is a exothermic reaction. Exothermic reaction. Why? Because a stronger triple bond is formed. Right? I calculated x after finding y by dividing equation 4 by equation and it was 2 divided by 3. Again, but you should get the same answer, right? Get the same answer. 2 divided by 1.2. You should get the same answer. The easiest way to do is things that will cancel out. Here also things that will cancel out. Here the things won't cancel out easily. Right? So that is why I did 2 1 by 1, 4 divided by 3. Anyway, you should get the same answer. The question number 47 is okay, ne? Right? 48 I won't do. We have done very similar questions. Take a 48. Okay. Right? But I 49 I'll discuss. Right? Question number 49. Let us discuss that as the very last question for today. On the 50th. Right. Question number 49, we'll look at this. Several experiments have been carried out by a student to determine the order of the reaction with respect to H plus in magnesium acid reaction. Can you remember that magnesium acid reacted? Magnesium plus HCl gives you magnesium chloride and hydrogen. There's a test tube where you make something like this and attach magnesium. This is a rubber band. And then you add HCl, it will collect hydrogen gas. Time taken to collect 10 milliliters of hydrogen, you measure. And the HCl is there, water is there, values are given. Write the balanced chemical equation for the reaction between magnesium and HCl, already done. Calculate the order with respect to H plus. So rate is equal to K times H plus concentration to the power simple A. Because magnesium is a solid, it doesn't depend on the magnesium concentration. Rate is inversely proportional to time. Time is equal to, let us say, K dash H plus ion concentration to the power A. So, first one is, let us say, 1 over 21 seconds is equal to K dash H plus ion concentration. Here the 0.1 times 12 divide by 25. Overall volume is 25. Simple equation 1. Another one. Second one. 1 over 16.6 seconds is equal to K dash times 0.1 times 20 divided by 25. Okay. So let us take 1 and 1 divide by 2. Here, 16.6 divided by 21 is equal to another 12 divided by 20 to the power a. All the other things cancels out. 16.6 divided by 21 is equal to 0.79. 12 divided by 20 is 0.6 to the power a. එතකොට a can be 1. හරිද අපි දන්නේ but 0.6 squared බලන්න. 0.6 squared is 0.36. ඉතින් ඒක වෙන්න බෑනේ, right? So a is equal to 1. මොනවද කියන්නේ ඔයාලා? Would you agree with that? හරිද? Everybody okay with that? ඊපස්සේ කියනවා write the rate expression for the reaction. What a rate expression ni කියන්නේ rate is equal k times H plus ion concentration equals to the power 1. Calculate the time taken for the experiment 4. එතකොට ඒකේ 1 over T is equal to k times what is the concentration? 0.1 times 25. 0.1 times 25. Total volume is also 25. Common in A. I think you can take 1 divided by make a 3 again. 1 divided by 3. 1 over 3. 1 over 21 divided by 1 over T is equal to the 21. 12 divided by 25. 12 divided by 25 to the power 1. So T is equal to 12 divided by 25 multiplied by 21 seconds. What has the 10.08 kilo. Is that clear? Is there a way to find A using log? පුළුවන් ඒක ඉතින් ඒක ගන්න පුළුවන්. log එකට පුළුවන් නේ. මොනවාද මෙතන එන්නේ 0.79. 0.79 is equal to 0.6 to the power A. Take the log on both sides. Log 0.79 is equal to A log 0.6. A is equal to log 0.79 divided by log 0.6. A then roughly equal to 1. Is it clear? So 10.08 seconds. So that is all done. Na? 49. Okay, 50th අපි කරමු නිකන් දිග it gives you a kind of a better sense නේ නේද නිකන් 50 කරලා තියනවා කියලා කිව්වහම right okay 50 right okay 50 ඒකත් නිකන් කියන්නම් මම order of the reaction is not necessarily the same as the stoichiometric coefficient of a certain reaction. Explain this statement concisely. එතකොට right it depends on the mechanisms. Depends on the mechanism rate determining step, right? If the reaction is an elementary reaction, right? That is the rate determining step. Then stoichiometries is the order. Right? Is the order. But So some reaction, it may take place in multiple steps. It might take place in multiple steps, several steps. So rate determining step stoichiometry is not the same as overall stoichiometry. So rate determining step stoichiometry is not the same as overall stoichiometry. Did you understand that statement? So some of these reactions, there's only one step. So overall stoichiometry and the stoichiometry in that step is the same. So order is equal to that. But some of these other mechanisms, it doesn't take place in a single step. It takes place in multiple number of steps. Then the overall stoichiometry and the rate determining step stoichiometry is different. Right? Right? That is the last thing we discussed today. QCl is a water-soluble chloro compound that undergoes hydrolysis slowly. Undergoes hydrolysis slowly in an aqueous medium. Assume that the rate of the reaction is expressed using QCl. Briefly explain a method to determine the order of the reaction. Right? Rate is equal K times QCl to the power n. First thing is you need to change the concentration of QCl. So change the concentration of QCl and prepare 5 solutions. Now you can you see it's gradually, very slowly generates Cl minus. QCl, you add to water, very slowly it generates QOH and you get HCl. Slowly and it hydrolyzes. Hydrolyze means you break using water. So it's generating HCl. That is one of the things that you can do is you add a consistent amount of silver nitrate. Consistent amount of silver nitrate. අපි අර මතකද අර sulfur formation එකක් කරේ? We did the sulfur cross formation. Amount of silver nitrate is added. So when you add silver nitrate to this, this silver nitrate gradually starting to react with the chloride formed and it will form silver chloride. Silver chloride is a precipitate. Precipitates gives you a turbidity. Turbidity. So you prepare a solution, QCl, different solutions, and you add the same amount of silver nitrate to everything, and you place it on a cross and keep on looking at it. Like the sulfur reaction. Thiosulfate HCl reaction. Right? And what happens is gradually you get a silver chloride precipitate, turbidity, and you can keep on looking at a cross and measure the time taken to disappear the cross. So, ඕම cross එක තියෙනවා. Look at the cross and measure the time taken. Time taken for the cross to disappear. For the cross to disappear. තේරුණාද? Did you understand that? I think this is connect. This is like, get the reaction, silver chloride, silver nitrate, and chloride reaction gives you silver chloride. Silver chloride is a precipitate. Precipitate gives you a turbidity. When you hydrolyze it, you get chloride ions, and it says it's not going to instantly hydrolyze. It's reacting very slowly, and the sulfur reaction also. They come up. They ask you to come up with some kind of a method. Did you have alternative methods? Well, were there any alternative methods for you to think? Anything you thought? Someone is saying here, sodium thiosulfate is added. Because there's HCl forming. You can add sodium thiosulfate as well and form sulfur. I think this is much easier. Make a balance. That's okay. It's a good method. Right. Next week. Next week. මට kinetics වල කරන් එන්න ඕනේ 51 52 53 54 54 55 55 වෙනකන් කරගෙන එන්න. Right? So up to 55 in kinetics in මොනවාද මේකේ මොනවාද then we did it up to 40 නේ. So 41 to අඩුම ගානේ 45 වෙනකන්වත් equilibrium and at least part of aldehydes and ketones. ඒක කරන්න. If you have finished aldehydes and ketones, then I'm very worried when you do these ones. Gradually you can work it out. At this point, I will stop. Right. I'm sure you're sleepy also. Right. Children, good night. See you on Saturday. Right. Bye.